That's excellent. Then we just go forward to the next speaker. That's Dr. Sabry Razick. You saw also his help yesterday in Jonas's session. Sabry is Chief Engineer for the Department of Research Infrastructure Services at the University of Oslo. Sabry is currently working there as a chief engineer. He is responsible for machine learning infrastructure team at the department and also provides advanced user support for the Meta Center, which is the national coordination for high performance computing system located in main universities of Norway. So Sabry, he holds a master's in engineering from Chalmers University of Technology in Sweden and a PhD from University of Oslo, where he focused on building IREF index, which is a consolidated protein interaction database. So you actually not only have the background in the infrastructure and machine learning, but also in protein databases and protein structure, I guess. So today, Sabry, you will speak about the Fox cluster at the University of Oslo and requirements for running AlphaFold and RoseTTAFold. Please, Sabry.
Thank you, Klaus. So my presentation here is a slightly shortened version of the original one. Because some more interesting things are coming up later on. First disclaimer, so what I'm going to talk about is not a performance comparison of RoseTTAFold and AlphaFold or the scientific validity of the results. It is just the setup we have on our shared system. We'll provide both the tools to our users so they can do their research using these installations. So there might be some wrappers, some versions that you will not, some scripts, additional scripts you'll see throughout the presentation, which are not available on the main developer site, because we wanted to provide a way for our users so they can easily switch between RoseTTAFold and AlphaFold and do the same analysis in the same sequence. So they could just rerun and compare. So that's just a disclaimer before that. So the Fox is a very small cluster compared to our other Norwegian clusters we have. It has 3,000 cores. For example, a normal laptop would have 4 to 8 cores normally. So it has 24 regular nodes, we call them. So it's slightly different than your like a regular computer. So these are like pizza boxes, no screens, no keyboards. You have to connect to them over a network. So these are based on AMD and a lot of memory and very fast disk drives, and very fast, very efficient interconnect between them. And we also have 3 nodes with about 12 NVIDIA 100 GPUs. For graphical user, GPU-based processing. So this is sort of like tiny compared to our Betsy cluster. We have about 172,000 cores, but this one is very specifically focused for the University of Oslo users and researchers. So get on board on HPC, for example. So there's so this is just an introduction about to get some understanding about the cluster, how you connect to it. So from your laptop, you use a program called SSH to go through the internet or network and land on the cluster. So this is slightly different paradigm shift. It's like not like a big shift in how you work, but it's slightly different than your usual work. You don't start a program and wait for the output in your laptop. Instead, use a program to connect to the cluster, and then from the cluster you land on like a welcoming node or a logging node, and there's like a farm of computers behind that to the actual processing. So all these computers have a shared drive, like they have access to the same data. So scientific software on our system, the preferred method to install things on HPC system is to obtain the source code and the source code of all the dependencies and compile them locally using a toolchain. So this is a very tedious process if it is like a new software. The reason for this is to optimize for the underlying hardware itself. There are certain instructions in the processor that might be not available in general. For example, certain instructions on the NVIDIA card we have, which might not work with the precompiled libraries. So we have to optimize the code to work on our system itself. So this is mainly to optimize the use of shared resources. If you think of a single researcher, the researcher or student, they want to get the results very quickly as possible. In addition to, we have to entertain a lot of people at the same time to the same computer. So if one person spends too much time doing something, then that resource is occupied, so the others can't use it. So the optimization is important in that sense as well. In addition to that, we can buy hardware. Right? If a processing takes 100 years, we can't buy time, right? But if we can recruit more hardware and do the 100-year processing in 1 hour, that's like possible, but we can't buy time. So that's another reason. So the Easy Build project, which is a project they are working very hard on making this AlphaFold. Actually, the dependencies of the actual AlphaFold compiled to a system level optimized version. We have also, I will also mention a little bit about how we have installed it. So AlphaFold on Fox. If you go to the AlphaFold website, so this is basically a set of Python script for us. What's behind is a set of dependencies where they give for example, a Docker file. So they say, get this information, get this libraries and install, and so on and so forth. So here what happens is they use precompiled binaries, and this Docker file, it runs on Ubuntu. Like if you get this file, if you install Docker, and on top of it run this Ubuntu image and run software on top of it, then that optimization that we are trying to reach will not be there. So, and in addition, we don't use container technologies like Docker on our shared system. We use other systems like Singularity to convert this Docker into Singularity. It's possible, but there are certain API calls, for example, in this AlphaFold that makes it difficult. In addition, it accesses a lot of data. So in that sense, we have installed this as a module. For example, I had to, I told you before that we had to go to the SSH and log into the cluster. In this, we have the AlphaFold module. So you don't activate Docker or any other additional software. You will load the module, and it's at your disposal, like certain set of with all the dependencies. Then you will see that there are additional things that we have installed in addition to AlphaFold that needed at the end. For example, you will see here TensorFlow, for example. So that's the thing that we have to do. So in this case, even in RoseTTAFold, we had to reverse engineer from what they provided. So in the RoseTTAFold, they were providing a conda installation, which is also pulling precompiled generic Unix binaries from the conda repository and install it. But I had to mention here that we have not compiled every dependency that needed yet. So we are cheating a little bit. We are also using mixing some precompiled binaries because they are very hard. For example, the JAX, for example, we need Google's Bazel compiler system, which is hard, but the EasyBuild team would soon come up with some compilation options. In addition, there's a lot of data involved. 2.7 for RoseTTAFold and 2.2 for terabytes for AlphaFold, which is very beneficial in a shared system. So for all the 150, 200 users, we only need one of these data sets in the one central place that you can access. In addition to that, yes. So I told about that. So then much more optimization possible. So this is a comparison table of how long it takes for analysis to finish. I have not compared with other like systems. So if there are people in the audience who have some idea about, so the second column is number of amino acids in the sequence. So how long would it take for a file with 905 amino acid residues to complete? So we could do it within like 1 hour, such a process. And we have pumped a lot of resources to it as well. But not all the resources it pumped in were used by the software, because that means we have more optimization left. So there were, at some point we found out that the RoseTTAFold, I think it was only using GPU 0. For example, even if you give 4, it will always use 1. So who can get access? So I have to apologize first because I think all the participants were informed at some point they could get access to this cluster. So at the moment, it's only for University of Oslo students, staff, and their collaborators. Because of that restriction, we have also replicated the same setup on the Saga HPC cluster, which will give all the Norwegian resources researchers access and their collaborators. And we will also if time permits, we would also help if any other HPC system they want to get these modules up and running. Because the analysis of this protein folding, these two software would be greatly limited by the hardware resources they have access to, like not the they need a lot of not something that could individuals afford. So they have to use some sort of shared system. And you could use cloud resources, Azure or Google or Oracle, for example, but it's going to cost a lot of money in that sense. So in long term, I think this setup is cheaper, but getting this installed and maintaining is also not that easy. So I'm not going to talk much more about it, especially because this was more specific for the Norwegian participants. If you need help, for example, get this software up and running, you could drop an email. So I will help if I could. And the analysis and the cluster, the Slurm code, which is like a wrapper batch script, which tell the cluster how to do the processing there. And there is some results are available on this GitHub page, publicly available. But don't use that results to, for example, do a comparison between RoseTTAFold and AlphaFold. This is just a technical take of this, not a really scientific interpretation. So class, I'm going to stop there. And if there's any specific questions, we could go and answer.
Thank you very much, Sabry. And also Morten Dern has joined, as you can see. Morten is central leader of D-Science, Center for Data Science and Computing at University of Oslo, and also professor in mathematics and informatics. So if you have any questions here, I could ask maybe Morten, what is, or Sabry, the idea behind the Fox computer. First of all, by now, University of Oslo has access. All Norwegian could have access to the national infrastructure, but do we have plans to open it up also for anyone also abroad? You're muted, Morten, if you want to answer.
Yes, I'm muted now.
Yeah,
thank you very much, Klaus, and congratulations with a very good seminar. Unfortunately, I haven't had the opportunity to join all the seminar, but it's an impressive number of participants. When it comes to what we do here, as you know, we are working on access to international facilities and national facilities together with other universities and research institutions in Norway. When it comes to FOX, this is an investment at the university, initially done for research at the University of Oslo together with partners. However, through the EduCloud system that we are about to establish, we also want to open this for other groups as well. There are, as Sabry mentioned, some technical aspects around that. But to be a part of an international community, we also want to open our facilities for other research groups outside universities. When I say that, it is also not restrictions, but there is capacity, of course, that is also has to be evaluated and thought about, because FOX is not a very big supercomputer, but it's a supercomputer for us at the University of Oslo, and we use it for training purposes to utilize national and international facilities as well. So the stunt that has been done over the past 2 weeks by USIT and Sabry to get the AlphaFold and RoseTTAFold up and running is something we are very proud of, and this is something that we want to do also in the future in order to establish collaboration nationally and internationally around these interesting topics. So again, this is a start of something that we want to take further on, in particular in the context of NORA, the network that you are heading, Klaus. So
thank you very much, Morten. So if I understand you correctly, now we have RoseTTAFold and AlphaFold installed. We have the competence, Sabry and many others, to test him and so on. So this could in the future then be utilized also for collaborations abroad. So maybe people could contact NORA then, or you, Morten, or Sabry, if they want some collaborations on this.
So any comment from you, Sabry, on the technical details with respect to collaboration? And we have established EduCloud, which is some sort of a mechanism to introduce external users outside our primary network at the university. How will that work in the near future? You said a few words about it. Do you have some additional comments to that?
Yes, Morten. So the thing is, the EduCloud is in a sense to provide the Norwegian researchers and students collaborative opportunities, because this cluster is purchased from like Norwegian taxpayers' money, and it will not be opened up widely to the world in that sense, but it will be opened up for everybody who's going to collaborate with the Norwegian researchers. So it's a sort of from our side, we are like encouraging people to collaborate more. So if you have like collaborator in the US, that collaborator will get access. So it's just, it's not without strings. Sorry.
Yeah.
That's understandable. So the solution is come and collaborate with Norwegians. We have also a question from Enda Farrell. Thank you for this info. I'm wondering, is AlphaFold, RoseTTAFold very sensitive to the specific NVIDIA GPU model apart from A100? For example, Tesla V100, K80, T4, etc.
So the V100, it should be okay. But we had issues on GPUs with low memory. So it was running like buffer overflow errors were there. So on NVIDIA, because we have a lot of memory, it was okay. But with more optimization and more customization, I think it would run, but you would need a graphic card with a lot of memory at your disposal. Let's say if you're sharing it with another person, like another user, it might not run. So these statistics, this analysis was done on a machine dedicated for that, for one user. So yes, there's a not a GPU related, but not on NVIDIA. I think we will also test on AMD GPUs later on. It's not a GPU brand related thing, but amount of memory related.
Thank you very much, Sabry. You will also be here, I think, for a little while. So if anyone have questions, please write them in the Q&A, and Sabry will answer. Thank you then, Sabry and Morten. I think you'll then take a short break and be back